Um, One thing I can tell you right now is that uh, if you're writing your code, an else statement without an if statement is illegal. This this is illegal. I know it looks a little confusing right next to the if statement, but anyway, if this was used uniquely on its own, something like then this is illegal. So else without if is an illegal syntax. So this doesn't make sense. Compiler doesn't understand what it is. So just to clarify that else is an optional part of if statement. So an if without else is quite popular. So sometimes you just want to analyze the condition and do something with that regard, but you really don't care an alternative. So you really discard the situation where the outcome of the condition is false, and you really don't care about that. So with the block of statements using the curly braces, this would be my choice always. And there are, in the past, my thinking was, and this sort of like predates Java, predates the days when I started writing Java code. In the days of C programming, to begin with, just reading C book, I always thought, okay, not using braces just like this is quite nice because it sort of like saves space. You don't have to waste your time typing and opening and closing brace, but it really kind of hits you when you have to add more logic here. And like I said, if I didn't have braces here and I wanted to add something else and forgot that now I definitely need braces to formulate a single block statement which will involve all of this, then I would be in big trouble because again, if I didn't use this, right? If I didn't use braces, then and perhaps this actually could have a brace, but this if I didn't use braces here. So this if doesn't have braces, it really applies to only one executable statement right next to it. But this one is really has nothing to do with this if statement. It just stands on its own. It just sits in the scope of main method, and this else now applies to it, right? Because now we say if variable 1 equals 1, then print this, and then else otherwise just do something else. So this is completely wrong. So I strongly advise always use braces. It is just a very good habit to have, and it will spare you from chasing strange bugs, especially when your program changes. So it's safer. Okay, what else? Um, if else, we already discussed. Then else provides an alternative. It's called else clause, and it provides an alternative to evaluating this condition. Of course, we can have multiple statements under each block statement that belongs to both if and else. So more than one statement, naturally. And what should be mentioned here right away is that when we start using strings, so for example, I wanted to say string string 1 equals 1, and then another string str2 equals 2. So now I have two strings, right? And kind of silly words placed in them. So now if I wanted to say if I wanted to apply the same logic, so let me simply copy and paste this part and modify it for strings. So I wanted to analyze, instead of analyzing 1 and 2, now I want to analyze string 1 and string 2. And also say that, let me get rid of this if statement, which was just for the demonstration. So saying strings are the same, or strings are not the same. This is a bit of a pitfall because, well, first of all, let's run this. It says strings are not the same, and you might think that what just happened was that string 1 was compared to string 2. Clearly, you know, starting from the first character, strings were not the same. So, which, you know, each one of them starts with different text, and therefore they're not the same. So it tries to deceive you to think that perhaps what's happening here is that we're comparing strings. But we are comparing strings, but we're actually comparing locations of them in memory. To clarify, real quick, let's go to Paint. So I will, you know, test my Paint, you know, or Scratch drawing skills again here. We'll see how that works. So we have string 1, right? String 1, and we have string 2. But remember, when the strings are constructed by those two declarations, what happens is that the two strings are constructed as objects in memory because strings are objects, and I prefer to use 3D drawings of those things. If I be careful and finish this, all right, so there are two strings. They're located someplace in memory. Of course, they contain different characters, right, because the strings are different. And string 1 is pointing to this location. It's a reference variable. And string 2 is another variable which is pointing to a different location. And this is where 1 characters are stored, and 2, you know, individual characters are also stored. As you know, each character takes 2 bytes in memory to store because it's like Unicode format. And so when I use double equal sign, what happens that this double equal sign, and I'll write it vertically. The double equal sign in this vertical thing compares those two references. Does not compare the content of my objects. It compares the addresses of string 1 and string 2 in memory. It compares references. That's the nature of the double equal sign when it's applied to objects. Strings are objects. Strings are not primitive types. Primitive types are compared literally, essentially saying, okay, what's the value? Let's compare the values. With strings, which are objects, as well as any other objects, it's not the content, it's not the actual values of objects that are considered. Rather, their locations in memory are analyzed. And it just happens to be that naturally one string and another string are located in 2 different places in memory, and therefore, you know, the outcome was that strings are not the same, if you recall what got printed. Let me do another trick and say, okay, how about this? Str1 equals 2. So I kind of force strings to really have the same content. Okay? And rerun this program. And the worst part of this exploration into string comparison, if you will, is that now it says the strings are the same, which might suggest that everything that I'm telling you is wrong, that this picture is wrong, that you know, when I go to try to tell you my story about references and actual objects, that my story is wrong, Because now that I said string 1 equals 2, we're now comparing string 1 to string 2, and hello, it brings strings are the same, which is great. It seems to be working pretty well and be an evidence against me, the things I'm trying to tell you. But what happens here is this, is that in reality what happens is that what happens when I say string, let me restore this. What happens is that when I assign 2 to string 1, what happens is that obviously we lose this object in memory. It's being discarded because strings are immutable. Every time you assign to them, brand new object is constructed. And what happens is that the compiler is smart enough to notice that this exact string 2 is already in place. It's in memory. So all it does, it simply takes and sets this reference to point to the same object. And that's why we're still comparing addresses. But the outcome is that the addresses are now the same. So basically now we have one object that contains the text 2, and the two references compare pretty well, and we get the outcome of strings are the same. So you may experiment more. At some point, this will not work properly. So let's save this segment.